we are at the end of our unit titled Quadratic Equations and Inequality. And as we are to the end of our unit, more of you are asking how can they use the quadratic equations in their real life.
Yes.
It is why we thought that we could teach here the lesson applications of quadratic equations, whose objective is, at the end of this lesson, the students will be able to solve problems involving quadratic equations in the real life. I mean that if you meet the problems in your real life, you must be able to solve those which involve the quadratic equations.
Yes.
Now, before to continue, here we have a problem of the real life. We have got a rectangular basketball grounds. We give its border 20 meters and its area 21 square meters.
Yes.
Now we want to find the length and the width of this rectangular basketball ground. Perhaps we have to buy some materials to build this ground. We need to know what is the length and the width of this rectangular basketball ground.
Yes.
Now, before to solve this problem, we can make a short revision about what we studied. Here we have the first task. I think that it is clear there.
Yes.
So that in the following list, what are quadratic equations?
Yeah.
Now, this is the question which is asked to you. What are the quadratic equations in the list given to the blackboard there? Yes? This is the revision.
Okay. As you see, we have some of the questions there. One is not quadratic question. It is not quadratic question because they have no degree of 2, but it is the linear equation.
Now, my question is to know, so we said that in the following list, what are the quadratic equations? That's the answer to the question.
No.
So it is good, but if there is someone who can make better to answer to this question, the question is to know, in this list, what are quadratic equations? So this is the question, yes.
Okay. In this list of 4 equations, the quadratic equation are equation number 1, equation number 2, and equation number 4. Equation number 2 and equation number 4 are quadratic equation because it is in the second degree.
Yes.
Okay, what do you say about this answer? So the number 2 and number 4 are quadratic equations. You could give the reason there because they are of the second degree. Yes. You can correct here, right? Because they are the formulation there. Because they are of the second degree. They are correct there because they are of the second degree. They. Okay? They are of the second degree. Yes. Very well, flowers. Let us go now to the second sub-question, the second task. So this is the first task. We could write it like this, as it is on the task there. Now, write quadratic equations in terms of sum and product of roots. Yes? So the second sub-question.
So I'm going to calculate. I'm going to calculate this question in terms of sum and product.
Yes.
For 2x plus 3x plus 1 equal to 0. For the first, I will divide this quotient to these numbers.
And you can also do it in your exercises book, yeah? But you have nothing to do. So you can look for it also in your exercises book.
For the first, I write the formula of the sum and products. X squared minus x plus product. So, I'm going to divide this quotient into that number. Sum equal negative 3 over 2. And the product equal 1 over 2.
Okay, good. Now, as she answered to the question, yes, she gets the sum and the product, but the question is to write this quadratic equation in terms of the sum and the product of the roots.
Yes.
Where is now this equation? In terms of the sum and the product. Yes? So it is good. It can help you.
As you know,
Continue there.
the quadratic expressions in terms of sum is like this. It means that coefficient of x squared is 1. It means we divide both sides by coefficient of x squared.
Yes.
It means we get x squared plus 3 over 2 x plus 1 over 2, which is equal to 0.
And we get now the sum equals.
Sum is equal to negative 3 over 2. Because to get this one, this quadratic expression in terms of sum and product, we multiply sum by negative. It means we get negative 3 over 2. And product is 1 over 2.
Okay, very well, flowers. So we could write this, we can write it to this state. Okay, it is not wrong, but we can write this to this step. We have not to repeat it. Okay, even if we clean here, it is not so that, it is not good.
Yes.
Now we can continue, we can go to, so here I said that this is to the step there.
Yes.
Now let us go to the second equation. The second equation now. Yes.
X square plus x minus 6 equals 0. The sum equals minus 1. The product equal minus 6.
Okay? Yes. Now, because there it is, how can you explain this? She said that the sum is minus 1 and the product is minus 6. Yes.
For me, I think there is no question there.
There is no? Yes.
Because sum is minus 1 and product is minus 6 because the quotient is 1 and we take x and we take one of that x in sum and divide by 1 and as we know the formula of sum is minus. We know that the formula of sum is minus p over a. Minus p is minus 1, this one, and over a, 1.
Okay. Now, it is like this, flowers. We can write this under the form of the sum and the products. And here, there is no problem here. When we write x squared minus x, sx plus p, yes?
Must be equal to 0.
Okay. Now, let us solve now our problem. Let us go now to the solution of our problem. Now, you can form the groups, 5 groups of 6 students, and the task which is given to you is to express the border and the area of this rectangular basketball ground in terms of the length and the width of the basketball ground. So we can form the 6 groups. This is the first group, width, the first group, the second one. Here is, you can come here. Here is the third group. Here is the fourth and the fifth. And you will choose in your group your team leader. Do you understand? Yes. Choose in your group your team leader and your secretary. You have 10 minutes for your task. At this time, you must have finished. express the border. It is not necessary to write to express the okay, write only in terms of there. If you don't know. Border, you put the word equals 220 here. Equals 220. Oh, here equals 220. Okay. Here. Then, yes. Now you can put the brackets here. Yes, so this is 1 and 2, we get this and we solve it. Now, so if there is something you don't understand, you can ask me, I can facilitate you. Why do you reject it? Because we can't get a length which is the dimensions of this ground. Because we can last find the dimensions of the ground. So even if you solve the equation, but you want to solve a real life problem. Have you finished there? No. If you have finished, even if we are not up to the time, we can solve our problem. Now, you can come back to your places. Okay, we can start by which group? So here it is asked to express the border and the area in terms of the length and the width of the basketball ground. Someone can come and express the border of this ground in terms of the length and the width. Then we have solution of our problem. Now, don't clean there. Oh. Okay, you can do it there.
So the question is to find the length and width according to the garden. The garden will have the perimeter of 20 meters and the area of 21 meters square. Solution. As you know, the perimeter of garden is equal to the 2 bracket length plus width equal 20 meter, and the area of garden equal length times width equal 21 meter square. Now before we calculate the length and width, we may transform in this in quadratic equation as we studied. So before, we must look the two equations, the method we can use. So I can use the method of simultaneous equation. So before we move, we can move this bracket according to the 2 times length equals length plus 2 times width equals 2 width equal 20 meter. And the L, this is correct. Length times width equals 21. This is the equation 1 and equation 2. There we can divide both 2 because I have the two or even number. We can divide 2, remain length plus width equal 10. This is equation 3. Now we can to join these two equations to form the quadratic equation. So before, as we know the length of rectangle is greater than width, we can find their length. Length equals 10 minus length. So now we can transform those equations into linear quadratic equation by substitute this length into number equation 2. Equation 3 into 2. So we have 10 minus length times width equals 0. No.
If you want to tell him
equals
something, you must put up your hand.
21. So 10, we must remove this bracket to collect the equation. Length times 10 equals 10 width minus L square equal 21. So we can move the 21 into left side into right side. 10 L minus L square minus 21 equals 0. According to the quadratic equation, we can start by the high degree. We may start minus L square plus 10 width minus 21 equals 0. We have this minus. We can put out of bracket minus 1 in order to get the correct equation. For example, we get L square minus 10 L plus 21 equals 0.
Now what is this equation?
This is the quadratic equation.
Right there. Okay, very well. You can go back to your place, and before to continue, you can write this in your notebooks. I think that you can finish to write this in some minutes. Write in your notebooks, and after that we'll continue. Yes. Solution of the problem. As you have finished right there, you can come, someone can come and plane here. We'll continue to look for the length and the width of our grounds. Clean the revision also. Revision, yes, okay. Now you can put down your ball pen. Someone can come now and look and solve this quadratic equation. Yes.
This quadratic equation, we find two numbers we can add and give us 10, and when we multiply them give us 21. Those numbers now are 7 and 3. When you take 7 times 3 equal 21, and when you take minus 7 minus 3. When you take minus 7 times minus 3, they give us plus 21. And when you take minus 7 plus minus 3, they give us minus 10. And I group 2 by 2. Minus 3 L minus, because when you take minus times minus here, minus times minus here, they give us plus. We minus 21, no, minus 7. Minus 7, 4. And L minus 3 equals 0, L equals 3. And the length, the width is minus 7, no, 7. And this is rejected.
Yes. Tell us, why do you reject L is equal to 3?
The length of rectangle must be, they cannot be different.
Yes? You can go and tell her. So it is good, she can help you. From which step?
My answer in that question, length here is bigger than the width. This reason for error 3 is rejected because my answer length is 7 because it is greater than this 3.
Yes?
Before to reject this one, we must compare this length we get when this L is equal to 7 and this length we get if L is equal to 3, and compare those values. When we get L, this one length is less than, we reject those one.
You can continue there.
For L is equal to 7. For the first equation, we have length plus width is equal to 10. And it means L plus 7 is equal to 10. L is equal to 10 minus 7 is equal to 3. For L is equal to 3. L plus 3 is equal to 10. L is equal to 7. And here we have this length is greater than this one, this width. It means this one, this L is equal to 7. It must be rejected because it gives small length.
What the objective? Okay.
Then length is equal to 7 meter and width is equal to 3 meter.
Okay, very well. Pause. Now there is a problem here. I want to know, can we go from this step immediately to this one, or there is a step which is jumped there? Who can come and write this step? Yes? You can write it here.
As you see here, we have right terms. So we have to go L minus 3 and L minus 7, which is equal to 0.
Okay, so you must put this step. But here you have also forgot something. Those equations, how are they? They are equivalent. And like this, we have solved our problem. Now, as we have solved our problem, we are to the end of our lesson. We can now look for, in our daily life, other situations where we can use the quadratic equations. We gave you some 2 examples here. You can also look for, in your daily life, some situations where you can use the quadratic equations. It can be in your physics course, It can be in your chemistry course, in other your subjects you are studying. So you can get other quadratic equations. Now you can take note of this, and there we are to the end of our lesson. Thank you very much for your participation.